students, in this video, there are two parts. First part is actually Baffle and its different types, and second part is Woofer, tweeter, and high frequency speakers. So let's start.
Good morning, students. Myself Dr. Shantini Bhattacharya, Assistant Professor of EC Department, SRM Institute of Science and Technology, Kattanpullu, Chennai. Today I am going to start a new topic of the consumer electronics. This is buffers and infinite buffers. Uh, Already I have completed so many parts of consumer electronics. So if you didn't watch, please go through it. I hope all of you can understand better if you watch these videos, this topic. So starting with Baffles. So what is Baffles? So first of all, here what is the thing I have written? So first of all, I will read this part. The edges of the cone can be extended with some rigid flat material. Okay, so that means you can see this picture. This is actually the loudspeaker cone. Okay, back portion, the loudspeaker, rest of the part is there. So here this is actually the cone. Okay, so edges of the cone can be extended with some rigid flat material. So edges of the cone, that means this is the edge. So here this part is actually the extra material by using any flat surface. Okay, so that what will happen, so we can, this extended part we can call as a baffle. So what is the need of this extended part? Okay, that means sound wave from the rear must travel out to the edges of the material before they can meet the sound wave from the front and interfere with them. Okay, so what is this? Actually these lines are typical. Okay, so what is the meaning of this? Okay, so that means there is some, this is the loudspeaker cone and this is some extended part. So when sound wave generates, it actually comes in the front direction as well as in the back direction. Okay, so if this extended part will be not there, then this back sounds also come with the come and mix with the uh, front wave sounds, and it will be some interference happen, so sound waves we cannot hear properly. So for this purpose, actually what happens, this extended part we have to use. So for this purpose, this rear, that means back sounds, they have to travel this distance from here to here. So it makes some times. Okay, so it will be, so we can avoid this interference. Okay, so when we go to the next 2-3 slide, it will be, I think, more clear. Okay, so this added material is called a buffer. Okay, so at that moment you just think that this cardboard type area is called the buffer. Bubble should be made of good sound insulating material and soft enough to prevent rattling. Okay, that means it is basically used for better sound purpose. Soft wood are satisfactory. Basically, like cardboard type material is basically used, but material it is called the celotex. Okay, now what are the significance? This is a very important part of the buffers. So first point is prevents front and rear wave cancellation. So what is this? This is the main part of the buffer. So what is this? So speaker driver radiates sound both forward and backward direction. Okay, I have already said when speaker generates the sound from both direction, that means front side and back side, sound waves are coming. Okay, so rear sound wave is out of phase with the front, so back sounds and front sounds are out of phase. Okay, so if we allow this back sound with the if we allow mix with the back sound with the front sound, that as it is out of phase, then what will happen, it will cancel out each other. So the it will be very so sound wave not comes clearly. Okay, so it basically happens in the bass frequencies, that means low frequency. Okay, so buffer increase the distance the rear wave has to travel, reducing the destructive interference. So as there is in the previous picture I have seen, as there is a extended part, so rear wave has to travel this entire area, so it takes some time. So it will be helpful for the low frequency response. Okay, it actually reduces the destructive interference. Okay, then next point, reduces edge diffraction. Okay, when sound wave hits the baffle edges, they can reflect or diffract, causing frequency response irregularity. And next point is what? Properly designed baffle with rounded edges can minimize these issues. Okay. Third point, shapes the speaker's dispersion pattern. The size and shape of the baffle influence how the sound is spread into the room. So, what is this thing, size and shape? I will discuss it in the next slide very beautifully. I hope you can understand more. Okay, at that moment, just you can, as a topic wise, you just listen. Then, next slide, I will explain it more. Wider buffers help with low frequencies relativity, while narrow buffers aid in better high frequency dispersion. Okay, now I am going to the next slide. This is actually the type of buffers. So here you can see different types are there. This is a flat buffle. Flat buffle means only the extended parts are there. No, there is any that means box type anything. Nothing is there. Okay, but in that case some open back buffle, that means it is extended and goes up to this. Okay, extended goes up to this. Here it is closed. Here different one by one I am coming. Okay, so this is actually when I am going all this buffles clearly, then you can understand how the shape and size of the buffle actually increase its performance. Okay, so first of all, you have to know what is infinite buffle. Infinite buffle means it actually that means the infinite buffle is actually a bed speaker of mounting. Its size is advantageous in an ordinary home. That means infinite means there is an extended part will be so long. Okay, but it is not in application wise it is not possible. Okay, so we have to reduce its size so we can we can use in our various application in home application. Okay, so because of the size problem, various arrangement have been developed to get the same effect without so much space. Okay, the true infinite buffle totally eliminate doublet action. Doublet action is a very important term. Doublet action means this the interference between rear wave and the front wave. Okay, so rear wave and front wave definitely it will interfere, but if we can manage that rear wave comes late, then it will be helpful for any loudspeaker. Okay, so now one by one I am going flat open buffle. This is a flat open buffle, that means the extended part only there, no box part is there. So this is a simple flat board with the speaker mounted in it. Sound from the back of the speaker can easily reach the front, causing phase cancellation as low frequencies. So here, as it is a no this type of extended part is not there, so whatever sound is coming from in the back portion, it travels this distance and come in the front side. Okay, so anyhow it will come. Okay, so this is also a problem. Okay, then open back baffle, that means this part is open, so it is more advantageous than the flat open baffle. What is the advantage? You can see that this portion is extended, so the when sound waves are coming from the back, then it travels more distance. It can travel from here, like that quickly travel from here to here, it is not possible. This part is totally closed. Okay, so partial enclosure behind the speaker reduces rear wave interference slightly more than a flat baffle. Okay, then closed baffle, it is you can say almost an infinite baffle, fully enclosed box. That means it is we can totally cover the rear waves with the from the front waves. Okay, fully enclosed valve isolate the front and rear sound waves, preventing phase cancellation and improving burst response. Burst response means low frequency response. Okay, then wall buffle. Wall buffle, this is actually the wall buffle, so more nearly a true infinite buffle. Speaker is here, you can see speaker in this side. Okay, in this side, and back portion is this side. Okay, so here this portion, that means this portion is not extended so much, but the front wave portion is extended so much. So if the sound, back sound has to come to mix with the front wave, so from there to travel and then come in this way, so it takes also some time, so it will be more better. Speaker is mounted in a wall or large surface, greatly minimize interaction between front and rear waves, considered ideal for flat low frequency response. Okay, burst reflex response, this is burst reflex response, has a, there is a one opening is there to enhance low frequency output, uses a rear sound waves through a tune port to strengthen the bass. Okay, this is another structure of the baffle. Then Helmholtz resonator, according to the scientist Helmholtz, the name is like that. So it is more refined bass reflex design using resonant tuning. So, and last one is drone cone inverter. Two speakers are there. It is fully covered, so we can actually as much as possible we can minimize the interaction between front and rear waves. Okay, includes passive radiator, that means drone cone instead of port, enhances buzz by using air pressure changing to move the passive ones. Uh, Before that, I have already completed what are the loudspeaker, what are the working principle of loudspeaker, what it is characteristics, then different types of loudspeakers. So these are the another types of loudspeakers. So woofers. This now is, I think, very name is very well known to all of you. So few more information you have to remember. So what are this information? Basically, woofers is basically the type of loudspeaker that is basically designed to reproduce low frequency sound. That range is 40 hertz to 1 kilohertz. Okay, it is a main component in the speaker system and is responsible for bus and sub-bus audio. And what are the subwoofers? Subwoofer is actually some add-ons with the speakers. So it is also designed to reproduce very low frequency sound. The range is 20 hertz to 200 hertz. Okay. So these deep bass sounds are felt as much as heard, like the rumble of thunders, then explosion in movies, or heavy bass in music. Okay. So how woofer works? So basic working principle is like all other speakers. Okay. So all other loudspeakers. So this is the really the basic speaker loudspeaker working principle. So what is this? There will be definitely one voice coil will be there, then one permanent magnet is there, and the diaphragm is attached to the voice coil, and this is the cone like structure and sound waves are coming through it. What is the working principle? As there is a permanent magnet, definitely one static magnetic field is there. So when electrical audio signal is audio is a signal is passing through the voice coil, then a varying magnetic field is produced. So when due to this production, due to this varying magnetic field and static magnetic field interaction, the voice coil continuously moves back and forth. Okay, then A diaphragm is attached to the voice coil, so as a voice coil moves up and down, then also diaphragm also moves, and due to this movement sound waves are coming. So this is the first point, audio signals sent to the voice coil. This orange path, audio signals are going to the voice coil. Voice coil creates a magnetic field. I have already said that as it is a varying audio signals, so varying magnetic field is produced. Electromagnetic force move to the coil. That means interaction between the magnetic field generated by the permanent magnet and the voice coil that produces the varying magnetic field. Due to this interaction, voice coil move back and forth following variation in the audio signal. Then diaphragm moves also starts, and sound waves also coming to the ear. Okay. Now, what are the key characteristics of the woofer? Okay. So, it is already I said this is very much useful for low frequency response. So, woofer handles the lower end of the audio spectrum, sounds like drum beats, bass, guitars, and deep vocal tones. Okay. Larger size, they are usually larger than tweeter to move more air and produce deeper sounds because it's actually work on the low frequency. So for this purpose its size is very large. So when we will go to the tweeter or high frequency loudspeaker, you can see that its size will be reduced. Okay. So its common size ranges from 6.5 inches to 15 inches or more. Okay. Design, the woofer cone is made of material like paper, plastic or metal and is designed to vibrate slowly to generate bass sounds. Power handling, woofer often require more power because low frequency sound needs more energy to reproduce accurately. And enclosure matters. What it is telling, that woofer performance depends heavily on the enclosure or speaker cabinet. Sealed or ported box help enhance bass responses. Okay. So now we are going to the next speaker. This is called mid-range speaker. That is actually it basically reproduce for the middle range of the audio spectrum. Its frequency range is near about 250 hertz to 2 kilohertz to 5 kilohertz. Okay, 5 kilohertz. So what are the characteristics? So as its little bit frequency goes higher, so also its size slowly it reduce. So usually size is 3 to 6.5 inches. Okay. Previously if you see the its woofer size is 6.5 to 15 inches or more, but now its size reduces 3 to 6.5 inches in size. Okay. Often paired with woofer and tweeter in multi-way speaker system, provide clarity and detail in the most sensitive hearing range for humans. Okay. What are the applications idea? Home and car audio system, PS system and also studio monitors. Okay. Now we are going to the extended range speaker. So it is reproduce as much of audio spectrum as possible using a single driver, and frequency range is 80 Hz to 18 kilohertz or more. Okay. So what are the characteristics? Usually single driver design may include special features like visor cones or face plugs to help extend high frequencies. No need for crossover, which can simplify system design. Often used in compact or minimalist speaker system. Applications area: small audio system, portable Bluetooth speakers. Okay. Now we are going to the high frequency loudspeaker. High frequency loudspeaker also you can say the tweeter. Okay. So this range is basically the upper range of the frequency. Okay. So it is denoted as 2 kilohertz to 20 kilohertz. Okay. So just like woofers and mid-range driver, tweeters use voice coil. The working principles are same. Okay. In overall all the speakers. Okay. So it's uses voice coil, magnet, and cone or diaphragm, but they are smaller in size. Now size is reduced. I have already told from the first slides that when the frequency goes high, then size of the that means overall size will reduce. So it is now 1 inches. Previously in the woofer you can see it is almost around 15 inches, okay, or more than that. So now it is going to 1 inches or less. Lighter and faster moving to respond to high frequency vibration. Use dome, horn, ribbon, or piezo technology to achieve high frequency accuracy. Okay, so this is actually, these names are basically based on their structure. Okay, what are the purposes? To produce treble or high pitch sounds such as high notes of vocals, string instruments like violins, synths, and audio effects, sharp transient sounds like that. Okay, then these are the, basically I have already told in the previous slide, there are some names are there. Based on the names, tweeters are different types. Okay, so dome type tweeter, horn tweeter, ribbon tweeter, piezo tweeter, planar tweeter, planar magnetic tweeter. So what are the and that means specification? That means in the dome tweeter, basically most common type of tweeter, dome shaped diaphragms are there, so its name is dome tweeter. And what is its property? Smooth and wide dispersion. Okay, horn tweeter, diaphragm mounted in a horn structure, very efficient and loud. Okay, ribbon tweeter, use a thin metal ribbon as a diaphragm, extremely little fast response. And piezo tweeter is basically, from the name you can understand that piezoelectric material definitely there will be used. Then so it is inexpensive, durable, doesn't need crossover. Okay, and then planar magnetic, similar to ribbon but with different structure, high clarity and audiophile grade. Okay, so thank you so much. Keep watching my videos. If you have any doubt, then you give me your doubt in the comment section. I will try to solve your doubts. Thank you. Keep watching.